Hey, today we're going to talk about 3.8, Human Population Dynamics. So take a moment and review the enduring understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. Okay, so now we're talking about specifically human population. So we're going to be looking at some questions and some practice problems here. So I just want to show you a few things. First of all, globally, the population density, this is a map that shows relative population density around the planet. And if you notice, the highest population density is in India. Gosh, don't quiz me. I think that's Bangladesh. This is South Korea, pretty high. Also, we have Belgium is up there, or that's maybe Holland. Nigeria, Puerto Rico. You're testing my knowledge of geography right now. This is China for having a very high population. The density is not as high as India. India's population is actually going to overtake China within the next maybe 10 years. But it's on track to do it within definitely within our lifetimes. You don't really have to know relative population densities, but understand that like India, China have very high populations. In fact, United States, Indonesia, Russia are all like the leaders in populations. You should definitely know China's number 1, India's number 2, US is number 3. Okay, Brazil's up there as well, but Indonesia, and this is all changing over the next 20 years. 30 years, especially a lot of these developing countries are going to, because they're growing quite rapidly, they're going to overtake and make it much higher. Their populations are going to be much higher. So Thomas Malthus had a theory, and he was a population demographer, studied the demographics of the population, and he determined that the human population will grow exponentially. However, our food production will only grow arithmetically. Now we have a problem when the human population overtakes the amount of food that we're able to produce. And this led people to wonder, what is the carrying capacity of the Earth? So as we will discuss in future lessons, there were modifications, or there were major breakthroughs in food production that allowed us to increase our food production. However, this theory still stands. We still don't know technically what the Earth's carrying capacity is. It could be anywhere between 9 and 12 or more billion people. So I think 9 is like on the lower estimate, but upwards of 12 or higher is on the upper estimate of the Earth's carrying capacity. So we're going to look at some questions. Now we have some new terms, but I just kept this equation up here because this is the one way of calculating percent growth. And another way, this includes births and immigrants. But another way of calculating growth, and it's called the rate of natural increase. This is just babies being born and people dying. So this measures the crude birth rate and the crude death rate. And crude just means per 1,000. So the crude birth rate is per 1,000. The crude death rate is per 1,000. When I have this equation, I divide it by 10 because per 1,000 divided by 10 is actually per 100. So I will automatically get percentage without having to multiply by 100%. So the original equation that we looked at before, we multiplied by 100%. When you're dealing with natural increase, which sometimes they'll call this the growth rate as well. It's not consistent. But when you're dealing with crude birth and death rates, that is the average per 1,000. So you just divide your final number by 10, and you don't have to multiply by percent. So it'll automatically be in percent. Let's look at one right now. So the question reads, in 2020, the United States had a crude birth rate of 12 per 1,000 and a crude death, and a crude death rate of 9 per 1,000. Calculate the percent growth for the U.S. in 2020. So let's look at let's plug in our numbers. Crude birth rate, 12. Crude death rate, 9. Great. Nothing else. We're calculating the rate of natural increase. So let's simplify this. 3 divided by 10 is literally 0.3%. And that is the final answer. You are not multiplying by anything to get to percentage. It automatically is in percent. Great. Let's look at another one. In 2020, Canada's RNI, or rate of natural increase, was 0.2%. If Canada's crude birth rate was 10 per 1,000, calculate the crude death rate of Canada in 2020. So this one is a little bit different, but we're doing exactly the same thing. We're going to substitute, and now we're solving for the crude death rate. So it's really 0.2 equals 10 minus x divided by 10. Since I'm dividing by 10 over here, if I multiply both sides by 10, I will get rid of this denominator, which makes it a lot easier to calculate. So let's go ahead and do that. 2 equals 10 minus x. What is x? The crude death rate is 8. Now, to calculate doubling time, you follow the rule of 70. Now this is the rule of 70. It's actually not 70. It's like 69.3 or 69 point something, but it's close enough. So we call it the rule of 70. Somebody figured this out for accounting, and it happened to work with populations. So this is what population demographers will use. Again, 70 divided by the percent growth. And again, you don't have to do any conversions with the percent. Whatever the value is in percentage, you just use that number, ignore the percent. So calculate the doubling time of Canada in 2020. And we already calculated the doubling time of Canada, or we already calculated the percent growth of Canada from a previous question. So if you go back and look, Canada's growth rate was 0.2%. So x equals 70 divided by 0.2. When I do that math, it's 350 years it will take Canada's population to double. Now, when you see questions, especially if it's multiple choice, it's going to be the approximate doubling time. So all of these values will be approximated, and it will say approximate something to that effect, because you cannot actually calculate the exact doubling time. And this is also assuming that the population grows at a steady rate. Let's look at another one. Calculate the doubling time of the United States in 2020. And again, we calculated this already, the percent growth. So I'm just using this number from before. So x equals 70 divided by 0.3. And that is 233 years. Sorry, I kind of did it fast. Didn't give you a chance to think about it. But anyway, the United States, growing at the same rate in 2020, will double its population in 233 years. It doesn't matter what the original population is. As long as you plug in the numbers, this will work every time. So the standard of living is basically it's measuring how high your quality of life is based on wealth and access to necessities or comforts. So standard of living is related to the gross domestic product, and that's basically how wealthy a country is. It's also related to necessities, like for example food, water, and shelter. It's also related to comforts, like entertainment and heat. Now, technically, we don't really need heat to survive. I mean, you could, give yourself clothing. I mean, I'm considering this to be a comfort, but basically all of these things together indicate the standard of living. So the gross domestic product is related to the country, how wealthy a country is. And based on how wealthy a country is, individuals may be able to provide specific necessities, but all of these factor into a country's standard of living. This can lead a higher standard of living, can lead to a higher life expectancy. And a higher life expectancy can lead to changes in the population. If people are living longer, the population could start to grow, assuming that if the fertility rate doesn't change. And that can impact biodiversity. Remember all of the HIPCOs that we talked about in previous lesson. So as the human population increases, we are impacting biodiversity globally. So to practice for the FRQ, you're going to do a math problem. The current global human population is about 7.6 billion and is growing at an annual rate of 1.12%. Assuming the global population grows at this rate for the next year, calculate the number of people that will be added to the population. So what I would like you to do is calculate this. I want you to show your work. Every time you have a math problem, you need to show your work. So I want to see the work for this question. I hope that this video was informative. There was a lot of information in there. I think it was informative. I thank you very much for your attention, and I will see you soon.